want to first welcome everybody from wherever in the world you're joining us from. Good morning, good afternoon, and good evening. Again, my name is Jeff Bonkowski. I am a retired career firefighter. I'm still working with the fire service and doing trainings and working with volunteers. So I've got 30 plus years of fire service. And in my career, I trained to learn as much about hazmat and hazmat response training to the level of a hazmat specialist. And I was also a paramedic. So anyway, through my career, I tried to learn as much as I could about these high hazard fires because we keep reading in our fire journals and our different trade magazines and even hearing on the news how firefighters are injured and killed and exposed to carcinogens and things like that. So through the presentation, I hope to address some of those, but my goal and even the goal of HCT, Hazard Control Technologies, is to work to make the profession safer by encapsulating and using this new technology. And today we're going to be talking about, industrial hazards. And when we sit there and we start going over this, there's so many different areas that we can look at. We're going to be keying in a little bit on the fire suppression, some spill control, vapor control, dust control. And I want to mention a little bit about the dust control because, in many instances, we hear about firefighters being injured or killed or even employees. And a lot of it is because we don't get training. We don't have the training. So hopefully we'll, talk about that a little bit further on. And then the new up and growing situation that we have is lithium ion batteries and how rapidly they're growing within our businesses and our areas. So my objectives is, one, I'm going to talk a little bit about the differences between, what we are used to, which is foam, and an encapsulator agent. Hopefully giving you an idea of the difference and how that difference makes so much difference in how effective they are at being able to extinguish fires. We're going to talk about, the proper applications and percentages and things like that you'd use when you're using the encapsulator. And then hopefully, we'll talk about and identify some of the emergencies where the encapsulator agents can make a difference. So when we sit there and we start looking at, just some brief history, of agents, water's been around and for many years, that was the solution. And, as we sat there and we started to become more dependent on automobiles and petroleum became more and more widely used, we needed to find a way to deal with those types of emergencies when water didn't seem to work very effectively. And because of that, foam was developed. And in many cases, a lot with the military. And when we started out with foam, it was, a couple of agents being mixed together and causing some bubbles. And then as, again, some of the fuels became a little bit more difficult to extinguish, research continued on, foams improved. And then we came up with that aqueous film forming foams, the AFFs, which gave you a much faster extinguishment, but it ran off and you needed to reapply it more than some of the older foams. And then we sat there and we started looking at the history up to today, where we started removing the fluorinated ingredients. And when we start removing the fluorinated ingredients, the effectiveness of that blanket deteriorates. So then we start coming up with artificial ways to help create the bubbles by creating these foam generators and some of the other things. And as we get into the green foams, we'll see that, they're even less effective and in instances, many cases requiring 3 to 5 times more of the foam to be able to extinguish a fire that the fluorinated foams used to be able to deal with. So there's a lot of issues in trying and going and moving forward with your non-fluorinated foams and trying to eliminate and getting rid of those forever chemicals, the PFOS and the PFOAs that are causing groundwater contamination, health and cancer in firefighters and so on. So as we continue on, we're going to start now talking about the encapsulator agents and how it's different than foam and how they're more beneficial and able to extinguish fires that foam is not designed to extinguish. We sit there and we start to look at and answer the question, what is an encapsulator agent? It's a water additive, and instead of a bubble, the basic building block is a spherical micelle. And we'll hear a lot of spherical micelle talk as we continue on, because the spherical micelle is the important part of how this agent works and being able to extinguish fires, being able to encapsulate flammable liquids and vapors and so many other things to make firefighting much safer, as well as being able to extinguish these fires in an industry much quicker, needing less water, and so on. But we're going to talk about how it's able to work on both polar and non-polar, or hydrocarbons and alcohols. And when I teach this class to firefighters, I always point out in the very last, it says hydrocarbon liquids or vapor molecules. And I always ask the questions in my trainings of firefighters and people that are familiar with firefighting. Can you name me another agent currently being used in the fire service that can work on vapor molecules, can work on extinguishing or encapsulating or preventing those vapors from finding an ignition source and causing a fire and explosion? And we're going to talk about that as we go through the presentation. And then we're talking about how, encapsulator agents helps, with the encapsulation on a molecular level, where when we look at foams, the foams are working on a chemical, on a mechanical basis, causing a separation. When we get into the encapsulator agent, we're going to be dealing in more on a molecular level, where we're going to be encapsulating and causing the separations. When we sit there, we start moving and looking at the encapsulator agents. There's a standard, an NFPA standard that this agent falls under, and it's NFPA 18A, and it was just done here in 2022 with the most recent edition. And when you sit there and you start going through this standard, you'll see how it's able to work on all the different classes of fires. The A's, the B's, the D's, lithium ion batteries, and we'll get into that as we continue on. But one of the things that we really, and I want to key in right now, is again, this 3D fires, because we're all familiar with foam. And if we go into the foam standard NFPA 11 and just go down into Annex A11 of the standard, it's going to show that foam is not suitable for a three-dimensional fire. But yet, when we've been unable to extinguish some of these difficult fires at our refineries or at our manufacturing facilities or other areas, what do we do when water doesn't work? We use foam. And if foam doesn't work because we're dealing with a three-dimensional fire, probably 95% of the time. And in the standard, it states that's not what foam's designed to do. So let's learn about encapsulator agent and how it's different and how it's able to work on those. So we're going to go through and we're going to talk a little bit, because in the standard 18A is section 7.7. And that standard is going to refer back to that spherical micelle. It's the spherical micelle stability test. And it's very important to understand the test, because this is how we make sure that the product is working correctly. We take flammable or combustible liquids. We're able to encapsulate them. And once we've encapsulated them, we can put a torch across them and show that they are no longer a hazard as far as the flammability. And in many cases, we'll see how in spills, we're able to help mitigate and reduce those soil spills as well. But to give you a better understanding of those spherical micelles and how they're formed, here's a quick video that's going to go over just how those spherical micelles are formed. And it starts with our molecule. Our molecule is a polar head and a non-polar tail. The polar head loves water, wants everything to do to mix in and be with water, and the non-polar tails fear water and want to get away from water. So when we sit there and we introduce the concentrate into the water stream with an eductor, batch mixing, or however we do it, because those tails want to get away from the water, they orient so that basically they make what we call these spherical micelles. The spherical micelles then will travel out through the water stream and come out through a sprinkler system or a fire hose. And those molecules closest to the surface, because those tails want to get away from the water, they're going to break out, they're going to spin out, and they're going to put a skin on the surface of each and every water droplet. And this is the important part as well. When we sit there and we look at that ability to encapsulate those solvents, those polar solvents and the hydrocarbons, those millions and millions of spherical micelles, yet inside of each and every water droplet are what's going to help do that encapsulation. The other thing is when we look at Class D metals, when we look at some of these other fires where you end up with an explosion because of the reaction with water, you have to understand now we've put that skin on the surface of the water droplet. So by doing that, it's now no longer the water that's coming in contact with those Class D metals. We put that skin on there, so we're able to rapidly start cooling and being able to extinguish. And because we've changed that mechanism of cooling, okay, we no longer have to worry about steam. Okay, so when we look at, you know, some of these injuries on the fire grounds, possibly even in industry, where, you know, people are working to try to put out a fire using water or other agents, and they create steam and they get some serious steam burns. Again, when you look at the use of an encapsulator agent in your water, there's no steam because of that change up of the water droplet.
Technologies presents.
When we sit there and we look at this introductory video about encapsulator agent, the F500, I'll point out to the left side of the screen, it lists all the different classes of agents. As you watch the videos, I would like you to pay attention to black smoke turning white. In this particular one, the pallets on the left had been treated. If you look at this one, that black smoke disappears, it's gone very quickly. Here is a car fire. I know many people, you know, use a lot of water, plain water, when it comes to trying to extinguish a car fire. Yet here you're going to see using 20 gallons a minute, they use very little water. With foam, there's 3 application techniques. It's rain it down, bank it in, roll it on. With encapsulator agent, aggressively fight the fire. Here you have a polar solvent, alcohol. If that was foam, you'd be walking through a blanket, you'd be disturbing that blanket, and you'd be having to worry about it flashing back. And here's an example of a 3-dimensional fire. And you'll see the jet fuel is still flowing when the fire is out. He's doing 2 things. He's cooling the steel that's a reignition source. Those flammable vapors, the gases, the LPs, the natural gas, okay, very easy to extinguish. Lithium ion batteries, reports from various third-party testing continue to show how effective encapsulator agent is at being able to extinguish these types of fires. And again, that Class D metal, where I was just explaining how with water you get those explosions because of the temperatures that the Class D metals burn at. We've put that skin on the surface of the water droplet so we can effectively cool and extinguish that Class D metal without having those explosions. And then transformers. Here's an example. This transformer's totally failed. It's no longer arcing. It's no longer sparking. So it's now a Class B fire in a Class C environment. So that Class B fire can safely be extinguished using the encapsulator agent F500. So there's multiple industries that this can be very effective in, that we can have an effect on and that we can help. Because as fire departments sit there and deal with these, they don't only have an impact in many cases on the industry or the facility themselves, but in many cases they have an impact on the community, because you need to have evacuations. You're taking people and moving them from their homes. You know, there's many things that, you know, fires in these industrial settings can cause that have an impact. So if we can sit there and we can help show how effective an encapsulator agent is at being able to reduce those effects and being able to extinguish these fires and being able to put these fires out faster and quicker, hopefully we can prevent some of the secondary effects that those fires cause by having to have people relocate. We're going to talk about all the different extinguishing classes and the lithium ion batteries and big thing is I mentioned, this eliminates the steam. Okay. That ability to encapsulate is going to help reduce the smoke and improve the soot and the soot toxicity by in cases up to 97%. And it improves visibility. So, I mean, I've seen videos where, you have, a structure on fire at a large warehouse, and, and you have 6, 8, 10 multiple firefighters up on top of the roof. We can hopefully try to reduce that need by being able to improve the visibility by not having to do that ventilation. And if we're not creating that steam and we're reducing the temperatures, again, that's why we ventilate. That's why we cut holes in the roof. So everything that we're doing, okay, and again, now that requires less damage to facilities and less repairs, and hopefully get facilities back up and operational faster. I mentioned the PFOS and the PFOAs that we have in foam. When we look at our F500 encapsulator agent, it's 100% fluorine free. It's been tested and shown that there's no fluorine in it. It's non-corrosive and it's biodegradable. So it's able to rapidly and quickly help out. And, we're going to show and talk a little bit more as we go through how effective it is at being able to extinguish the fires using much less water. And if we're using much less water, it means it's less water runoff. Okay, so it's less impact to the environment, less impact to the community, especially if it's going to get into any streams or creeks or get into any waterways. So there's a lot of things as we go through here that I'm going to continue to mention and talk about. And I may be repeating myself, but again, it's important that you help you understand the difference and how this new technology is so much more effective. So again, I mentioned, and I'll again point out here as far as the benefits, that heat reduction, because with steel structures, okay, that's a source of reignition. If we're able to cool that steel structure, even though there's flammable liquids or other things around, that steel structure is no longer a source to reignite that fire. Okay, so we can eliminate those steel structures from being that reignition source, and how it's able to be in use with other agents. So again, as I said in the standard of NFPA 11, foam's not suitable for three-dimensional fire. It's two-dimensional. So if you have a spill or you have something taking place and there's steel structures around, F500 can be used to cool the structures. It can be used to extinguish that three-dimensional aspect of the fire while foam is being applied to suppress vapors. So we can use and be used in conjunction with, okay, it's not you have to use one or the other. To be used as a pre-treatment to help prevent. And there's been many cases and many things where people have come back and talk to us about how they've treated buildings, or they've pre-treated things when they're doing controlled burns in areas, and fire will burn up to and stop in areas where they've been pre-treated. And we always ask, well, how long does that last? And it's kind of a tough question, because we've had people that have told us, well, we tested it for 3 days. I've got a person that says, hey, I went and I tried to burn stuff for a year. I had poured diesel fuel on it, or I'd pour a fuel on it and I would light it, and he said the fuel would burn off and it wouldn't light. So we hear different stories about how effective that pre-treatment can be. And it comes in play when we sit there and we start looking at being able to protect exposures or nearby structures. So when we sit there and we start looking at, like many agents, when you add it to the water, the encapsulator agent F500 does reduce that surface tension water. It helps with that deeper penetration into hay bales and paper coils and other things. So it's very, very effective at being able to help break that surface tension and get that deep penetration that you're looking for to help you get into some of those deep-seated fires. And then testing has shown that it's effective on energized systems. Now here's a fire. I'm going to pause here for a second because I want this to play through, because the thing is, here's a large tire fire, one of the largest tire fires in the United States. And the reason why I want to let the video play with the volume is because all of the different names the encapsulator agent's giving, other than F500 encapsulator agents. So just me, as far as being able to understand the agent.
Then 1 million tires go up in flames at a dump just a couple of miles north of Coolidge. You can see it right there on the map. That sent a cloud of smoke thousands of feet into the air. Sky Fox arrived on the scene minutes after it all started. This was the scene around 3:30. Less than 30 minutes later, the second row of tires catch fire, sending even more black smoke into the air. And this was the scene less than 3 hours later, after nearly all of the piles had caught fire.
Dust, rain, and high winds. High winds that carried the dangerous smoke close to the ground and into nearby homes. Tonight there are evacuations, health concerns.
Good evening, everyone. It is officially a state of emergency on the Gila River Indian Reservation tonight.
Blaze has been to battle. It certainly has been a bear environmentally, but like us, firefighters are just watching some 16 piles of tires burn. Now, each pile is 175 feet long, 50 feet wide, and 60 feet tall.
Toxic smoke is responsible now for a second night of evacuations in parts of the Gila River Indian community like Blackwater. Bulldozers have been working since last night to push the 12 piles of tires that haven't burned away from the 16 piles that are burning. If they've moved them far enough, this fire won't get any bigger. Hope number 2 is a second shipment of firefighting foam, originally scheduled to arrive from Georgia at midnight, now expected around 3 a.m.
Firefighters say a foam chemical retardant seems to be helping extinguish the fire, and they are trying to arrange for emergency shipments of more foam and water.
Now, that fire retardant was flown in from Atlanta, Georgia, and trucked up here from Sky Harbor Airport.
And it seemed to have turned the black smoke into white. Then you add more water to it, then it seeps down and puts out the fire.
Well, we're going to show you, Marty and Scott, because it's the third day of this fire, and they have done a lot of work on it. You can see from up here now there are some piles that are still putting out that black smoke. Some of those piles, though, have changed to putting on a white smoke. The reason for that, they're putting a fire retardant on those. You can see the trucks down there.
That's right. This has been a very difficult fire to fight, but as you look over the scene right now, Rick Bogrant has a shot of a
Okay, I'm gonna stop it there. I think it's kind of made the point. It talked about basically a few things. Okay, one, just how rapidly that fire was able to spread from one pile of tires to the next until all of them were involved. Again, encapsulator agent early on could have kept that fire to just that one pile. They talked about the impact of the community, the evacuations that this fire caused, and the impact that it had for days and days and days. But yet then once they received the F500 encapsulator agent, how quickly they were able to get this out of control fire under control. Foams, waters, and other things didn't work. It was a three-dimensional fire. Okay, so we're trying to use basically products on fires it's not designed for. Here's a fire that deals with some ethanol.
F5.
You can tell again because of just exactly how clean it burns. When we look at some of these videos, if you watch and you look at the percentage that's being used here, when we look at flammable liquids, vapors or gases, and class D metals and lithium ion batteries, our recommendations 3% solution, we're going to see when they start to apply that they're not using big water. Here it is. It's a 120, or excuse me, this is a 95 gallon per minute nozzle. So it's not a lot of water and concentrate that's being used, very little to extinguish the fire. As you saw, there was no foam blanket. It gives a milky white discoloration to the water. And that's one of the things that when we do our training with firefighters, that we make certain that they understand that they need to watch for. And as I go on, I want to show this next video, and again I'm going to pause and let you listen to the news footage on this one.
Highway 225 is shut down in both directions too. Good evening, I'm Jason Miles, and tonight for Ron Trevino, the chemical fire started about 12 hours ago and is only getting bigger. Stephanie.
Okay. It's only getting bigger. It started with one tank, but we see what we have down here. We have multiple tanks, and when we get all done, it was like 15 tanks, and 11 of the 15 tanks were destroyed or damaged.
Highway.
And this was the cause of it. It was a simple manifold, okay, that initiated this fire, a three-dimensional fire. It could have been stopped right here with encapsulator agent. Okay, there is no need to lose any of the tanks. Okay, if encapsulator agent had been able to be used to work on this three-dimensional fire. So it's important to understand that, and I guess the biggest thing I'm trying to point out is, we need to look at this new technology. If we have something that can deal with the fires and the things that we're faced with that today's agents that we're familiar with aren't working on, okay, here's a solution. Okay, it's been here since 1997. Kill the volume there so you can hear me. Here's a distillation column. Again, on the news, I'll sit there and I'll listen and hear about refineries catching on fire or explosions and evacuations, and it's a distillation column. And here you saw just how quickly. Here's an example of firefighters with, again, another three-dimensional fire. You see the fuel is still flowing. We saw this one just a few minutes ago in the introductory video, that they're using that 3%. And again, when you sit there and you watch, he's applying it, watch him change the spray pattern on his nozzle from that broken to a little bit tighter stream. He's working to do a couple things: encapsulate those vapors before they can able to catch on fire, and then cool that steel structure because it's a form of reignition. Okay, we see a leak at like a wellhead or a valve, where they are having some difficulties, and you'll see using encapsulator agent F500 in the water stream. Okay, they're able to sit there and they're able to, again, multiple things. They're cooling this steel, which is a reignition source, while they're working to extinguish it. Natural gas or vapors. Okay, we look at a tank that was designed and set up to do some testing. You'll see just how quickly they're able to extinguish the fire. Again, a valve, put that fire out, continue to flow, because as long as you're flowing, you're continuing to encapsulate those vapors, and now you can reach in while you're still flowing, and you can turn that valve and shut it off without having to worry about those vapors finding an ignition source and flashing back, because you're encapsulating them. You're preventing them from being able to find an ignition source. You're controlling those vapors. And I'll talk more about the vapors here as we go on. When we get into the spill control, okay, and we have a lot of issues and a lot of things, where, hey, in the process of filling containers, there can be spills, overflows, and we can be dealing with flammables as well as corrosive materials. And we'll talk a little bit about how an encapsulator agent F500 can have an effect on both of those, how it's been proven to work. So when we sit there and we look at that neutralization, we are going to talk again about the difference between foam and an encapsulator agent. Where foam creates that blanket, it causes a separation. It does nothing to remediate or does nothing to eliminate the hazard. We now need to call in a specialized contractor to clean up the mess, to clean it up, okay, dig up the soil, and so on. When we sit there and we start looking at an encapsulator agent being used, again, we're encapsulating these solvents. We're encapsulating these flammable liquids, and we're helping to remediate them. As far as it being on a hard surface, cement, asphalt, those can evaporate away. They're not going to require any special remediation once it's been encapsulated. The biggest thing is monitoring to make sure that it's not releasing or that you've had the total encapsulation and it's not releasing any vapors. Once you've got that total encapsulation and there's no longer any vapors, again, that can safely evaporate away without having to need any additional cleanup. And when we look at the NFPA standard for foam, it talks about a 15-minute application. You got to do all of your calculations. If it's a flammable liquid, it's 0.2 for per the size of the spill. And again, you have to do a bunch of math and do some quick calculations, and then you got to flow for 15 minutes. And as that starts to deteriorate, if your cleanup contractor is not there to start performing the cleanup, you need to reapply it because it's going to break down. And to give you an example, is a fuel spill that happened that was brought to my attention at an airport. About 3,400 gallons of jet fuel was spilled. It was spilled on the tarmac. It was spilled on the roof of a pump house. And it was spilled on the grassy area that was around the pump house because there was a person that was trying to fill an underground storage tank, and he attached to the wrong tank, and he overfilled it. And instead of shutting things off, he panicked and ran. So all of this jet fuel is coming out of the vent pipes. And again, it was about 3,400 gallons that was given to me as the estimate. The foam that they were using was the mil spec foam because, again, it was an airport. So the crash fire rescues came out. They applied their mil spec foam, but because it was so hot, they were having to reapply it about every 6 to 7 minutes to keep those vapors down. They called the local fire department, and a utility company in the area is a user of F500. In fact, they have trailers that they make available to the fire service that carry 500 gallons of the concentrate. So they called, they had that trailer respond. I'm told they used somewhere in the area about 300 gallons of the concentrate out of this trailer. They sprayed down the roof, they sprayed down the grass and all the tarmac and all the areas that were affected. They allowed it to set for 20 minutes and then went through with their explosive meters or meters to check for LELs and to check for any flammable hazards, and they found none. So they were going to wait to the next day, let everybody go home. It's been a long day so far for them. It was hot, so they let everybody go home, and they said in the morning we'll get a cleanup contractor in here and we'll get this cleaned up. Well, when the EPA here in the United States and the cleanup contractor arrived on scene the next morning, and they started walking around with their monitors looking for an area where they were to dig, they couldn't detect any LELs, they couldn't detect any hazards. So they just dug up some soil in a couple different areas, found that there was really nothing, and they packed up and they were in and out. It took them longer to offload their equipment and do a little bit of digging than it did and load it back up than it did to really do anything. So the remediation was done, and we're just using a few hundred gallons of the F500. So it can make things very, very effective. When we sit there and we look at some of the other things as far as the abilities of this, if you're close to a waterway, and it happens to be salt water, the product's been used very effectively to degas ships, to be used on ships. It works just as effectively with fresh water and salt water. There's no difference, so it's very effective. And in many areas, like say, it's on the EPA's National Contingency Plan as a surface washing agent, so we allow it to just simply evaporate away, causing no hazards. So unlike your foams, which cause that separation and need to be cleaned up, this is going to encapsulate. It's going to actually help you remediate and help with the cleanup cost by reducing it. Now, one of the things I point out when we sit there and we start looking at some of our large scale fires, when we look at again, let's think back to that tank fire and things like that I was just showing. What's one of the biggest issues that we have? okay, when we deal with those. It's water supply. I mean, we can see from this picture, all the different hoses, we sit there and we get a tank farm and we're looking at, these fire streams that are going to be flowing, 5,000-6,000 gallons of water, and we're going to have multiple. What's that doing to our environment? Okay, when I go back and I sit there and I'll back up here just for a minute to this tank farm fire that I had showed you that started here. Okay, let's look at all of that water, all of that foam. That dike ended up failing because of all the water, and it polluted a part of a waterway or part of a bayou down in the Gulf area. And it's what that PFOS, the forever chemicals that we keep talking about. Okay, things that are going to have an effect. And when we sit there and we start looking at some of the effects that those chemical has, I can sit there and I can start, and again, share with you, just feel free to ask or contact us, but we can share with you different instances where in states they have do not eat the deer or do not eat the fish because of the forever chemicals that are in the ground in the areas where the deer and things are. Here again is going to show you a real quick video. I like to talk about this and use this with my firefighters, because let's say an auto accident where you have, victims that are trapped in a vehicle, or, even in the industry setting, if you have a flip spill and you have that fire impinging on some area that's important that needs to be protected. Here we see that they're going to spray that one half. The fire doesn't go across it. They're now using the encapsulator to extinguish the fire. But you're going to now see the person coming in the background with the torch. He's going to light it up. You see the milky white discoloration in the water. There's no and as he goes through this area, my video stopped. That. He's going to stop it. You can see him sweep his foot across, and I'll back that up just one more second. He's going to spark up his torch. He's going to walk on through, and as he walks through, he pauses to show it's not a blanket. Okay, he's going to pause. He's going to sweep his foot across. He's got the torch there. Now with foam, he would have exposed those vapors, and he would have had a fire. Okay, this encapsulated that flammable liquid, getting rid of that flammable hazard in that instance. This is a video because as I started this, I also mentioned not only the hydrocarbons or the flammable liquids, but I also mentioned acids. This video deals with sulfuric acid spill. If many people are familiar with sulfuric acid, when you mix it or you work or with any acid to try to dilute it or you try to neutralize it, you end up with some type of a reaction. And generally with the reaction, you end up with heat, or what's called an exothermic reaction. This particular incident happened down in Brazil. They actually started with a train that was carrying sulfuric acid. The train had derailed, causing a spill of fuel from the locomotive, the engine, as well as some sulfuric acid. When they responded to use the F500 on the fuel spill, they took by chance and thought, well, let's see what happens with F500 on sulfuric acid. And when they did, they found out that when they started to neutralize or they started to treat the acid, there was no cloud that was formed. There was no exothermic reaction. It was able to take the acid from a pH of 1 to a pH of 6 without that exothermic reaction, without that cloud. And it was important to this particular instance because here we had a tanker truck that had gotten involved in an accident and spilled the sulfuric acid out onto the roadway and onto the ground. And because of COVID and because downwind of this incident was a prison, the government didn't want to have to evacuate, relocate all of these people in the prison because of the spill and trying to mitigate or trying to clean it up. So F500 was brought in, and as you can see, it was used very effectively, being able to neutralize the acid and eliminate the hazard without creating that cloud, without creating the need to cause that evacuation. So now we've seen, the ability of this to work on your Class B fires and being able to extinguish those without having to cause community evacuations. And here's another example where it was used on now a sulfuric acid, another chemical, not preventing the need for that evacuation. So the advantages, when we sit there and we start looking, and we're going to use just a simple little 8-gallon fuel spill here to help you with that comparison. And it's going to get into that NFPA standard. So when we look at evap being able to do that spill, when we look at F500, you're going to get a neutralization. With foam, you're going to get a temporary blanket, because as I said, you're going to have to keep reapplying it as those bubbles break. So we look at 1 gallon of F500 to be able to neutralize versus 36 gallons of an AFFF foam. So with the cleanup of that, because you've now got 40 gallons, if we look at the formula, it's 1 part of F500 to 8 parts of fuel and 40 gallons of water. So you're looking at just a little over 40 gallons, but you now have a non-flammable liquid spill to clean up versus that 1,208 gallons of flammable liquid of foam. Because in many states, because of the PFOS and the PFOAs that are in the foams, that's now created, again, a hazmat. It's a reportable incident in many states. So the F500 is safe to leave the scene. So, you're done. You just let it evaporate away. But yet with the AFFF, you now have to, again, stay on scene so you continue to reapply it until a cleanup contractor gets there to be able to clean it up. So the foam needs to be cleaned up. The F500, allow it to evaporate. And as I said previously, it is on the US EPA list as a surface washing agent. So it needs much less agent. So there's a cost savings. When I sit there and I start back to that tire fire that you saw at Gila River, Arizona, that one pile versus, all of the different piles of tires that they had, that evacuation, much less water. I was reading in a report, somewhere, how about the wear and tear when we sit there and we start looking at the equipment? Because when I get into the industrial and I start getting into some of these different large scale fires at facilities, these costs are now being basically recouped. Fire departments are looking at cost recovery because it's such a huge expense to communities. Okay, they're starting to look at cost recovery ordinances. So they're billing back for the hours, not only of the firefighters, but the equipment that they use. So how many fire trucks were there for how many hours? Okay, how much diesel was used? These are all things that, fire departments are looking to try to recoup their costs and expenses on. So if we can sit there and we can start using, again, going back to that fire with the tires, that first stack of tires, or even let's go back to that tank farm fire where it was the manifold. Okay, let's look at the difference in cost. Okay, here you've been able to put that simple manifold fire out with maybe 10, maybe 15 gallons of concentrate versus the hundreds and hundreds and hundreds and possibly even thousands of gallons of foam that was used to try to put out the tank farm fire that, as you can see, looks like it pretty much burned itself out. So there's a huge difference in the cleanup cost. If I'm able to put that fire out with that manifold, or if I'm able to put it out with that first stack of tires, I don't have a lot of water runoff that I need to worry about where it's going. In that tank farm, it would have been confined within the diked area, within the area. It would have been there wouldn't have been any cleanup cost. Okay. We talk about that firefighter fatigue, hours and hours, possibly days. We heard the tire fire, 3 days, multiple days, versus once they started using the F500, they got it under control quickly. Okay. How much less wear and tear and how much fatigue. and what causes the injuries in the fire service, or what causes industry injuries and fatalities. It's stress and fatigue, people being tired and still trying to work. So all of these things can, and just with the use of F500, the benefits and the cost savings, are just multiplying as we continue to, discuss all the different applications. Now I'm going to get into that vapor control and the ability of it with those gases and how, we're able to have an effect. And we sit there and we start looking. I'm going to talk a little bit about Veep. And we sit there and we look at it and we'll learn more about it and how effective it is and how efficient it is. We'll see some videos. I'm going to talk as we go through. But, when we go back to that NFPA 18A, if we look in that standard in section N 12.8, there's a section that covers combustible, flammable, liquid, vapor, encapsulation prevention applications. Okay, Veep. Okay, so here in the standard, and again, I'm going to throw it out there. Can you name me another NFPA standard that has anything in it that covers the ability to prevent a vapor explosion? And chances are there are none. So when we sit there and we start looking at this technology using the encapsulator agent, and all the different applications and all the different uses, it's pretty much everywhere, anywhere. Your refineries and chemical plants, our power plants, pretty much any of our high risk industries. And, there's been so many instances where, we have these fires and we have these explosions because of flammable liquids and gases. And here's just a real, quick video. Here we have an area, where again, some employees do like to smoke. We have what we consider as a safe area. If you look at that, the fire didn't start, and I'll back it up again. The fire did not start. If you watch right here, the gentleman smoking, the fire does not start with him smoking. The fire comes from that bottom right-hand side of the screen. But, these are the types of things that can be prevented. But yet here we have employees that are assuming they're in a safe area being injured and possibly killed because of injuries that they sustained because of vapors that accumulated. And I show this because, here's some testing. We've got a water system. We've got some ignition sources that we have going on. You see them throw a flare in the bottom. They got LP, and you see water is totally ineffective. Okay, here is a single story of a water system, and trying to be able to prevent a fire from occurring when we sit there and we look. So now I'm going to speed this up just a little bit because they're going to open up some valves, and they're now going to go to a second layer of water protection on this test. And again, as you can see, we're flowing much more water on the bottom. You're going to see again flare come being thrown in through here. They're allowing those vapors to build up a little bit, and you'll see as soon as the flare gets tossed in there it goes. That water vapor, that water curtain does absolutely nothing in being able to, one, can really control or extinguish the fire. So a lot of water we're having run off. So when we sit there and we start looking at this video, so this was a tanker truck. I'm gonna kind of change it a little bit, but we're dealing with a gasoline tanker. Again, we're dealing with vapors. This gasoline truck had rolled down an embankment. They could not get the fuel offloaded, so they actually rolled the tank truck over and used the dome covers on the top of this tanker to empty it, using the F500 to suppress the vapors. And they used the vapor, and they used it also as they were sitting there and they were bringing this tank truck up the hill.
Hazard Control Technologies presents F500.
I'm going to show this video here real quick. This is going to, again, discuss and talk a little bit about that Veep system It's a real quick video. I'm gonna let the audio on this one play while I grab a quick drink.
Hazard Control Technologies presents F500 Encapsulator Technology. Industrial fires. They're one of the most dangerous aspects of any industry's production. One spark can cripple operations and cost lives. But now, even the biggest fire disasters can be prevented, controlled, and contained. It's possible, thanks to Hazard Control Technologies Inc., a breakthrough combination industrial vapor encapsulation, explosion prevention, and 3D Class B fire suppression system is now available. By combining HCT's F500 encapsulator agent, flammable liquid vapor encapsulation, and three-dimensional Class B fire suppression capabilities, with our VEEP rotating nozzles, a containment system was designed to control and contain explosive vapors, liquid, and gas fuel fires. Systems are available to cover areas both small and large, from pump transfer stations to loading racks and processing areas. Don't wait for the costly explosion and fire disaster. Prevent.
Okay, so I want to back this one up here just a little bit. I'm going to pause it here as we go through here because, you know, we saw in that other video where we had that tank, we had 2 levels of water protection, and it couldn't do anything to the fire. And yet here we have a demonstration using this
to cover
system.
Areas both small.
I'm going to kill the volume here. Using this, and you get almost instant extinguishment. Okay, but not only that, it's going to continue as long as that system is flowing. It's going to continue to encapsulate those vapors, preventing them from finding an ignition source and coming back and flashing back. So you have time now to be able to go into safety shutdowns, or being able to shut off valves, or being able to take the actions that you need to stop the flow of the gas or the liquid that possibly or potentially could be responsible for the explosion and fire. You can set off those safety devices and prevent that fire and explosion from ever occurring. Instead of a facility being down for days, months, you know, or years, depending on how much damage was caused, or, you know, rather than having loss of life or injuries, you know, there is a system out there that can be activated and prevent those from happening. Now, the next thing I want to get into is going to be dust control. A bad area again, in many times in different articles and trade magazines at granaries and at different facilities, we'll hear about firefighters or employees that are working to try to deal with maybe a deep-seated fire, taking action, trying to get the fire put out. And because of lack of training and understanding the hazards of these dust fires and explosions, we end up with people getting injured and killed again. So hopefully, again, this is an area where F500 and HCT can help you out and with training as well as the products. So the encapsulator agent and the grain process, it just like with so many others, they're high risk as far as the hazard, because in many cases, as I said, you know, the people don't understand all the hazards. They see a fire. They see, you know, a grain fire, a corn fire, a coal fire, you know, that's going on within a silo or a bunker, but they don't look at the big picture. They don't look at everything that's around them, okay, that could be part of an explosion should they take the wrong actions. And if we sit there and we start looking at a lot of these injuries, a lot of the damage at, you know, some of these facilities, we're going to see it's usually not what's called the primary explosion that does the majority of the damage. It's usually the secondary explosions or the tertiary, the third explosions that are caused by The first explosion shaking some dust and some things loose and creating a bigger hazard. So understanding these hazards are the number one priority with HCT and in helping to train people in dealing with these types of hazards and using F500. When we sit there, we look at this video, a great example. Here's a dust collector. You know, we have an industry setting. Again, all the years in the fire service, when we look at, you know, dust fires and dust collectors and things like that, there's little to no training, okay, on how to deal with these in the fire service. And, you know, firefighters, they see fire and they want to flow water without understanding the full potential of the hazards that they may be dealing with. And in doing so, taking the wrong actions can be detrimental. In this particular instance, luckily, nobody was severely injured. It could have been much worse. Here's an example. Okay, here's an example where, like say, there was an instance with a grain silo. You see the you know, the roof sitting here on the ground. You know, some workers with fire taking actions. The actions that they took weren't correct, and it ended up leading to a fire and an explosion that severely damaged the facility, and, you know, put them out of business, or, you know, it basically made it so that they were no longer able to operate for, again, a period of time until they got everything rebuilt. This video is video showing encapsulator agent F500 at 1% with a combustible dust and subbituminous coal. You'll see when they use plain water on the left with the coal dust, with an ignition source, a hot spot, you have a fire. You get a huge fireball. And those are the types of things that we're talking about when we're dealing, not understanding the potentials that you have in dealing with these combustible dust, especially when you're dealing with combustible dust in a confined space. Okay, if you're sitting there and you're using a water stream and you kick that up and you're inside of a enclosed structure, how much heat did you just cause? How much steam? Again, we talked about those steam burns. We could look at the video on the right where they're using the F500 in the water stream, and you'll see there's no flare-ups, there's no fires. He's having an effect. Do you want to go off and do it that way? Not without proper training. And again, that's where contact HCT. We'll be more than happy to come and do training with your employees. We'll be more than happy to do training with the local fire department, emergency responders, so that we can hopefully get you to better understand that hazard and keep everybody safe in the event you have that type of a hazard at your facility. Next one, as we continue on, is lithium-ion batteries. It's a growing hazard. It's everywhere, and it affects all industries and all people, because I mean, you sit there and start looking, if you're carrying a cell phone, if you're carrying a radio, you got a computer, a laptop, these lithium-ion batteries are pretty much everywhere we look. I mean, in a room that you're sitting in, you could probably turn around and look and maybe identify 6, 8, 10 items that might be within close proximity to you that are operated by lithium-ion batteries. So the use continues to grow on a daily basis. And we always hear the word thermal runaway, and being able to stop thermal runaway. And unless you're able to stop thermal runaway with water, we always hear reignition. Okay, a Tesla, 30,000 gallons of water, but it burned for 4 hours and they never really put the fire out. Boy, oh boy, that's a lot of water. What about all the HF gas? What about all the hazardous materials that were in the electrolytes or that were in the batteries as they burned up and you used the 30,000 gallons of water? So when we sit there and start to look at the difference again between water and an encapsulator agent, water to really be effective needs to do that steam conversion. It needs to, be able to use steam to help cool. When we look at a fire, in many cases, the water droplet is only what, 3, maybe 5% of the water droplet is used to cool and extinguish a fire. But yet when we add F500 encapsulator agent into that water stream, we can change that to that water droplet now is probably closer to 90, 95% effective at being able to cool and extinguish. And when we look at the lithium ion batteries, there's multiple hazards we're dealing with. Okay, and as I go through, we'll talk about those. We're going to see, okay, how these lithium ion batteries, okay, unless we can get that temperature cool down, okay, it's going to reignite itself. Okay, we're going to talk about the gases that are being released with these batteries, the HF gas, okay, which is highly toxic and very hazardous. When it comes in water, it creates HF acid, which attacks calcium in your body. Well, people are sitting there and constantly looking for solutions. Again, I'm going to go back into that NFPA 18A. And when we look at NFPA 18A, we go to Annex 4.3. Here is in a standard, an NFPA standard, and I believe it is the only standard currently that has any information on being able to deal with extinguishing a lithium ion battery. And within there, you'll see that it's agents that conform to the 7.7 standard that have been tested in this annex material. And the testing has been done has been done by some independent third-party organizations that include like the Kiowa, Dacra, Daimler, Deutsch, Bosch, Fraunhofer University, TL Clausel, and the list continues. And we keep hearing and getting more information on different organizations, being able to do testing on. And with TL Clausel, here it is, they used 50 gallons of water, and we're not successful in being, our 50 liters, of water, and we're unsuccessful, but yet with 4.3 liters of an encapsulator agent, they were able to extinguish a battery. So a huge difference when we sit there and we start looking at the differences. When we look at that HF gas that's being released, okay, one of the hazards, especially when you start dealing with some of these larger batteries and some of these larger areas, if there's batteries are in an area where maybe people are working, or maybe people have to go through to be able to evacuate the building, those HF gases can cause a toxic problem. And when we sit there and we start looking at some of the testing that was done on some of these batteries, they started to look at the HF gas that was being released. And when they were looking and doing that monitoring, they looked at the levels, and without trying to extinguish the batteries, they were looking at levels of about 2656 parts per million. When they redid the test using F500 in the water, those levels went from 2656 down to 37.45 parts per million. Okay, and if we look at the NIOSH, that gives you about, about a 10-minute exposure limit is 95 parts per million. So it gives you, if you look at some of the different guidelines, it's going to give you down to 37 parts per minute. It's going to give you a little bit of time to be able to safely evacuate and get out of a structure where these batteries may be burning. Or how about your home? We see these scooters that we keep hearing and watching YouTube videos on. Okay, it's the same thing. If we can sit there and we can have this, and when I mentioned that scooter, it just so happens my next slide deals with a video that's going to show a scooter burning. We hear the little pop, we start seeing it smoke, and look how much smoke's being released. Creates pretty impressive fire as well. Now I got a laptop. And we see this laptop, and it was not being abused as we could see. It was just sitting there on the chair being charged. And battery fails. Okay. Oh, did it overheat, overcharge? No clue what the cause of it was, but we can see just how effective or how damaging these fires with these lithium-ion batteries can be. So when we look at some comparative testing that's been done, this comparative testing was done on behalf of HCT Europe, Johnson Controls, and Kiwa Labs, and it was testing powders, foams, and F500 encapsulator agent. And when I show this video, I often ask, when we look at fire codes in all of our buildings, our high rises, our commercial buildings, our stores, what is the type of extinguisher that's required by fire code? It's a powder. It's an ABC. Okay. So while the use and the storage and on the shelves and every place of these lithium-ion batteries continues to grow, our fire codes aren't changing with the hazards that we are dealing with. So here we have a powder, as you can see, that's very effective. In the center, we see foam. Foam, very ineffective, doesn't work. Yet F500 was very, very effective at being able to extinguish those lithium-ion batteries. Okay, it's able to stop the thermal runaway. It works on multiple aspects of the fire, as well as the vapors that are being released. We're able to reduce, as we mentioned in that HF gas down to a much less toxic level. It's able to encapsulate that flammable electrolyte, and it's able to cool. So we're working on the ability to cool that battery so that it doesn't cause the reignition, just like we do with steel at those flammable liquids facilities. So we cool the battery down below the auto ignition temperature. We encapsulate the fuels so that the electrolytes in the batteries are no longer a hazard or a flammable, and then we reduce that HF gas. So now when we sit there and start looking at some of the innovative systems and the equipment, we have our carts that we have that come in two sizes. We have our QAMUs, what we call our quick attack mobile units, compressed air systems, mobile response trailers. We look at and do our training with the combustible dust and things. We talk about the piercing rods. And then when we look at those sprinkler systems, those fixed systems, now we're talking about, the water-driven portioners, our diamond dosing, different types of pipe systems or bladder tanks. The consulting and training, I mentioned through the presentation, being able to get you the information about combustible dust training, lithium-ion battery. I'll be more than happy. Contact your HCT at info@hct-world.com. We'll be more than happy to work with you to get you the training that you need in the different areas that affect your facility, your particular industry. So the consulting and training services are available. We want to work with you, partner with you to make your facility safer, okay, so that you have less impact on the community should an incident occur, okay, so that you have, again, the ability to help maybe get your first responders, your firefighters trained in new technology that can reduce the damage at your facility, okay, get you back up and running and prevent you from having downtime and being able to get you up and running and manufacturing and getting back into business much faster and much quicker than you might currently be doing. To take the time to thank everybody again. I, like I say, as always, enjoy being able to do these presentations and meet and answer questions and meet the different people that join us for these. I know in some areas it's late, and other areas it's early. So again, I really appreciate you taking your time out of the day to join us and to learn more about the encapsulator agent. You're the ones that are going to help drive this new technology in being able to deal with the high hazard fires that your communities, your industry, or your countries may be faced with, and being able to do it in a safer manner, not only to the community environmentally, but for the firefighters. So I, again, just want to thank you all and wish you all the best. Have a great rest of your day, and look forward to seeing you at our next webinar.